This conference will now be recorded.
Like there are a few commands which are yet to cover from the Docker side, hardly 15 to 20 minutes. So then we'll see the Kubernetes area today, right? So let me start the instance. From the Docker side, focus on the networking, like the network drivers, how the parts are getting communicated, like the network drivers. And also focus on the Docker files. Docker Swarm is not required much. We require the architecture level of knowledge on the Docker Swarm side. Compose, Docker files, Docker networking are the important area for us from the Docker side. Okay, right. So let's start our session. Right. So now here I am going to create a container, Docker run. Correct. So Docker run, then -dit, right? We know D for detached mode or daemon mode we are going to call, so that is going to run in the background. Right? I for interactive mode and T for terminal, right? So we know these options now. So now Docker run -dit, then I'm going to use Ubuntu. So I want to have a container for the Ubuntu OS. So service dot status start status Docker clear. So now we can observe here the Ubuntu container is running. We created 2 seconds ago. Right, so now here my requirement is I want to have a Git. I want to work with the Git. So to work with the Git, what we will do? So usually, either you can take the image which is available from the community side, then simply you will take the image, right? So, the advantage of Docker is that's what, right? So usually, if I want to have server or the machine, when there, what we are going to do is either virtualization or the Dockerization. So when we are going to talk about the virtualization, so there you have to have a machine. On the machine, you have to have a host OS. On the host OS, you have to install the hypervisor. On top of the hypervisor, we are going to create the virtual machine. For the virtual machine, we are going to use the ISO file. Those are the packed things, the ISO file. Right. So now here the thing is the maintenance, right? So that's a separate server, separate instance. When you create a virtual machine, it's a separate machine. The maintenance is our responsibility. Any patches, backup, everything is our responsibility. So maintenance will be our responsibility, and again, huge amount of resource allocation, right? So we are going to create a 1 GB of RAM server or 4 CPUs or something like that. Even though I am not going to use it because there is a minimum requirement like that. So when it comes to Docker, everything is gone. You don't require to create a server with upfront configuration. Right? Upfront configuration nothing but like our virtual machines, 4 GB of RAM. As an example, 2 GB of RAM, 4 CPUs. You don't require here. You don't need to tell anything. So whatever the application is required, that much of allocation your containers are going to take when you are going to create it. That's it. So then huge amount of resources are gone. And the second one is maintenance. You don't require to maintain anything because we are going to take the images. We are not going to set up anything. Right. So when you want to have the new thing, simply you are going to take the latest version. That's it. That's what the Docker. Right? So now here the image I have taken the Ubuntu. Now I want to work with the Git. If the Git image is available, simply what I will do, I will take the Git image. Suppose let's take an example of here. We are not finding any Git image from the community side. but you need to work with the Git. Then what we will do? Simply, you are going to take a mission, a plain vanilla mission. On that, you are going to install the Git, and you are going to start using it. That's it. Right? That's what our Docker files, right? The our own files. When our for our project, we are not going to find any default images. So for that, we are going to create our own images. So like that here, I want to work with the Git. So for that, I am going to install the Git on my Docker container. So for that, what I did, I have taken the Ubuntu server. I mean to say server means again here a container, Ubuntu container. Then I am going to connect, right? Execute is a command to execute the commands on the container, or we can connect to the container by using execute, right? So Docker execute -it, then our container ID, then the command to connect Winbash. Now we connected. So right for Ubuntu servers, if anything you want to install, first you require to update. So apt update, then apt install git. Right. So here I can see git is ready. Right. So now here I can work with my git, mkdir git repo, cd git repo, git init. Everything will work fine. That's so my git is ready. Now I'm able to work with the git. Right. So for that I don't require any separate instances, or I don't require to configure on my local machine, nothing but the laptop. I don't want to disturb my system. The containers are very very useful here. So now, right, fine, I'm good. So I'm happy that I got the git and start working on that. Then my work is done. I have completed my work. So then what I will do, simply I will come out from the container. So docker ps, the container will be running in the background. When you want, you can go and connect to the container, because we have given the option of -d run in the background, right? So now that is fine. So now by mistakenly what I did, so there are n number of containers are running in my system. So I thought of why unnecessarily those are running. Let's terminate it. So now what I did here is docker ps, docker rm hyphen f, right? We know the shortcuts, right? Docker ps hyphen a to remove all the containers. All are gone. Whatever the containers are running here, all are gone. Now I realize that I have terminated my git also after running this command. This is also gone by 6. Right now again I want to work with the right, because for temporarily I came up from the container from the git, but in future, maybe tomorrow or today evening at some point of time, I may require the git. I need to work with the git, but suddenly some of by mistakenly I have deleted it. Right, a kind of example I'm trying to give you guys. So means here your work is not done completely. It is a partial work is completed. Later on you require that one, maybe tomorrow or after 1 month, you don't know when you might require the same setup, right? So for that, what we are going to do, right? Because the containers may be terminated with multiple reasons. So there is a chance, if the server is not something, the server is restarted or something happened to the container, there is a chance of container gets terminated. So by that time, how we are going to get the things back, right? So this is one way. By mistake I have deleted. Some point of time you are going to lose the containers with other reasons also. So by that time, how we are going to get the state back? Okay, data. Now we know data can be get back by using the volume, right? We know very well the volumes are there to maintain the persistency, right? So whatever the data we are pushing into the container, that can get by using the volumes. But the configurations like git or any other tools I have installed, those how I am going to get that there the Docker files, right? So now the Docker files came into the picture, like to get the state back, right? So simply we are going to create the Docker images with the Docker files, and we are going to create the container. That is one way. The second way is, let's set up the configuration whatever you want, right? As an example here, I want to have the git. Right. So now here what I did, I have created a container. On the container, I have installed the Git. So this is the configuration I'm looking for. So this is the configuration I'm going to use in the future also. This is there. What I will do, I am going to create a image on top of this container. So I'm not going to write any Docker files. Right. So simply here there are two ways. One is create a Docker file, write a Docker file, and create the image. Place the Docker file handy somewhere so that you can create the images when you want. The second way is on top of the container you can create the images like ISO images, right? So the ISO images are nothing but you are going to set up the entire setup on the machine. Then on top of the machine you are going to create the ISO images. Right. The same way here also we can create the images on top of the servers, nothing but the container. So for that we have a command. Right. So now here again I am going to repeat the activity again. Now Docker ps Docker execute -it app update install. Okay. Just for confirmation. So yeah, Git is ready. So now here the command. So what is the command is required to store as an image. The container will be stored as an image. Commit. Commit is the command which is going to convert the container as an image. Right. So now here Docker commit which container you want to convert as an image, the container name or ID, then your new image name. Right. So now here what I will do, I will right. So right now I'm in the container. Let's come out. Now Docker ps. Now this is the container which is having Git. So now I want to create an image on top of this container. So now Docker commit and the container ID and here some name Ubuntu Git image. Right. If you want to point to any version, you can tag it like colon version name, version 1, version 2, like that. Or if you leave it as this, then it will take it as a default as a latest. Right. So now here enter. So now it is going to create image for us. It is going to create image for us with the name called Ubuntu Git image. So now Docker, right? We know the command is Docker images to see the images information. Right? You can see here Ubuntu Git image with the version v1. If you don't mention, it will be the by default latest. Right. So now here I have a image which is having a default Git along with the Ubuntu. So now Docker ps Docker rm -f, then I am going to remove this container. Now I'm not going to worry about it because I have the backup ready. Nothing but my image is ready. So now here Docker run -dit, then right. So our images Docker run -dit, then my image is going to git image version 1 Docker ps. Now we can see here the image pointed our new image. Docker execute -it git version. Right, git is there. Right, so here right, so likewise we can create the images on top of the containers like multiple ways, guys. Right, how we are going to handle it, either writing the Docker files or like this also. Like this also can create images on top of the container. This is one command. And you want to see the history, like what kind of operations are performed on that particular image. Like if you add, like now I have added Git, tomorrow I'm going to add Tomcat. Like now my image size is going to increase, right? So basically, if you guys observe here, now the size is 198 MB, right? So tomorrow I'm going to add some other package called Apache. So now here my size is going to increase 200 MB. Example, right? So when you're going to add the content means the size is going to increase obviously, right? So now here I want to see the history, right? What kind of updates are done on particular image. So that what we can do here, Docker history and the image name version 1. So 2 minutes ago I have connected to means I have executed the git version command, and these are the operations are performed on this what called this particular image. Like, so anything you have done on this particular image, those you can see Docker history. Like in our Linux, if you want to see in the past what are the commands are executed on this mission, right? So history is the command, so that you can verify all the commands whatever you have executed. Right? So in the same fashion on the image side, any commands are executed means any actions are performed, nothing but Docker history is the command. Just to see the history, to verify the history. Now, right. So now here, whatever the containers we are creating, those are belongs to your workstation, your local machines, right? So now here, whatever the containers I'm creating here, those are belongs to my server only. My server in the sense my mission, my working station, right? So now here, this work has to be shared. It's not like only you have to work. This has to be shared, right? So now here, I have done some operations, means some tasks I have executed. So now the other guy has to take up the load. Means whatever the task I have executed, he has to take up from that point actually, not from the scratch, because already I have completed. Suppose if there are 4 tasks, I have completed 2 tasks. Now my colleague has to complete the other 2 tasks, but he requires the information. Means whatever, because dependency is there. The first 2 tasks, like the 1, 2, 3, 4, like that you have to go. Right? If I'm straight away cannot go to the 3 as an example. So straight away cannot go and work with the third task, because there is a dependency is there, linking is there. So when I want to start working with the task means I need to understand what exactly done in the past means, or for the 2 tasks, what kind of operations were performed. Then I have to catch up for the third task. Those operations has to catch up for the third task. So there what will happen here is whatever the task I have used on the container, this has to be shared to my colleague. Then only can understand, I can start working with that. So now here, how we are going to share the load, right? So now here, there are ways, multiple ways, right? So the multiple ways are nothing but you can create a image, like just now, create a image. The image, share it to that guy, right? So how we are going to share it to that guy? So simple. We have a community called Docker Hub, correct? We have seen in our first class. So now the Docker Hub will have will be stored all of our images. So now here what we will do, save the image. I mean to say create a image, then push the image into the Docker Hub. Then the other guy will pull the image from the Docker Hub. That is the solution, the best solution, right? So now here the thing is, the Docker Hub is not in our project. So what are the project I'm working for? There is no Docker Hub. Means for the security reason or for some other reasons, they are not using the Docker Hub. Then then how we are going to share the images, right, the content, right? Because we require a kind of tool, a repository is required. There you can store all of images, so that from the repository anyone can access, right? Like our GitHub, right? So GitHub is for the purpose of the GitHub is the same, sharing between the team people, right? So now here when there was no Docker Hub, then how we are going to share? Still you can share the content. So that's what here the commands are called export and import. Right. So for the export and import, you don't need to depend on the GitHub. Simply can use the export and import command. Then with that export and import, you can share the content. Means the servers can be shared between the people. Yeah. So what we need to do here? If I want to share my container, my server to the other folks, then what I need to do here? So now from our end, who wants to share? That guy has to create a tar file, right? We know tar file. What is a tar file? Right? The archiving. Right? So now here the container will be converted as a tar file. Now the tar file can be shared, right? So straight away cannot share the container. It has to be converted kind of a zip files, right? So now here in our Linux we have a concept called zip and tar files, right? So archiving purpose. So now convert into a tar file the container and send the tar file to the folks, your colleague. Then the guy has to import the tar file as the image. Then with the image you can create the container. That is the process, right? So now who wants to send the container, the server, that guy has to create a tar file. Then the tar file has to share to the other person. Now once the other person receives the tar file, he has to convert the tar file as an image, then create a container with the image. That is the process, right? Let's see here. So now here I am going to convert my container as a tar file. So for that, export is the command, right? So now here docker cs. Now here you can see a container is running. This is the container, nothing but the git one, right? So now here docker export and the container id. Now here I'm going to give as git container tar file some name. So now a tar file will be created here. Dot sorry ls, right? So now here this tar file is created. So now here once the tar file is, then you can send the tar file by using emails or FTP, that SCP, right? We have multiple ways to share the files to other folks, right? We know that process. Now once the person is received the tar file, suppose again I receive the tar file. Now I want to convert this as a container, right? So that tar file, I cannot do anything with the tar file. I require the data, nothing but the server is required. So now here what I need to do, I require to convert this as a container. So not straight away you cannot convert as a container, right? So here the process is you have to convert as a image. Then image can be created as a container. We know with the image how to create a container. So now here to convert the tar file as an image, so import is the command. Import is the command. So now here docker import hyphen, then this is the name. This is the image name, right? You can provide any name, user choice. So here I have given some new Ubuntu Git image, some name I have given. So then less than, right? We know less than means sending the input, right? Greater than means writing. We know that is the Linux command. So now here your input is nothing but your tar file, git container tar file, right? So here git hyphen container. So now here this tar file will be generated or created as an image with the name new Ubuntu Git image. So now Docker images. Now we are going to see a new image. Simple. So now here I can create a container Docker run -dit. Docker run hyphen, so maybe it is not properly converted as image. That is the reason it is not showing. That we are not able to create the Docker run -dit. Ubuntu Git image. Yes. So here the thing is it is not properly converted as image, but yes, this is the process. This is the process of nothing but converting a container. Means converting a container means sharing the data, sharing a container, sharing a server between the people by using export and import. This is the process. So then the other command will be export the image as a tar file. Now, right now, what we have done here is we have exported the container to the right. So the container is converted a tar file, and the tar file is converted as image. Then the image can be utilized. So now here, now I want to export the image instead of the container. I want to send the image. So for that, save and load are the commands. Right. So now here, your image has to be saved as a tar file, and the other person will be load the image into their local machines. Now to save the image as a tar file, docker save is the command. To the other person, when the other person receives the tar file, he is going to load that image. So for that, docker load is the command. Okay. So now here, docker save -o, docker save -o, and this is some tar file name, and this is our image name. Ubuntu Git image, docker images. Right. We have the image, Ubuntu Git image. This is the image I want to convert into a tar file. The command will be docker save. -o is the option to provide the name. So now here, ls, a tar file is created. Now the other person, once the tar file is created, then I'm going to share the tar file to the other person. Now the other person has to be load, means the guy has to load the image, whatever the image is created under this tar file. Right. So for that, docker load is the command. Docker load, then less than is sending input. Right. So here, docker rmi, I'm going to remove this image. It is untagged, so now the image is gone. So I'm going to remove. Okay, so some content is running. That is fine. So anyway, I have untagged it. We don't have the image. So now let's try to load it. Now you can see load the image, Ubuntu Git image with the version we want. So now Docker images. It came back. Ubuntu Git one, we want. Right. So likewise, we can share the containers or we can share the images to the other persons. You don't require to have any kind of separate repositories like the Nexus or like Docker Hub. It is separate third-party tool is not required to share the data between the people. Like we have an options actually. Right? These are the interview questions, not in the real time. Real time obviously require the tools. They will go with the Docker Hub or some other tool to have the images. Right? But yes, we have an option from the Docker side. These are the interview questions, guys. So now here the other command, the other process from the Docker side is copying the data between the host machine and the container. Right. So copying the data between the host machine to the container means that if this is my mission, right, where the Docker is installed, my AWS instance. Now in this instance, right, we have installed the Docker engine. Right. So now here, this is my instance and this is my Docker. Now here, we are going to create the container. This is what, right? So now here, I have a file. I have a file called devops.txt where it is in my instance, AWS instance. So now here I have a container. So I want to copy this file from my host machine to the container. So this file I want to copy into the container. Likewise, vice versa. There is a file called here docker.log file. So now here this file I want to copy from the container to the host machine, vice versa. Right. So now here copying the data between the host machine and the container. Right. So now what you will do? Usually the volume. Correct. So the volumes are the solution to have the data. So now here if I am going to create a volume. So now this volume is suppose volume 1. So now what I will do? I will mount this volume to the container. I will mount the volume to the container so that whatever the data is pumping into the container, that will be stored into the volume. We know, right? So now here, suppose there is a Docker log file. So obviously, this log file I can find in the volume. That's what we know. But what about this dev.txt file? It's a file. It is located in some location, like under OPT directory or under data directory. It's not like in the volume. Right? The volume concept is whatever the data we are pumping into the containers, those will be stored persistently, not your data, not your server data. Right. So now here this file I want to copy into the container means what I need to do here is I need to copy the file from here to into the volume so that it will be reflected into the container. We know, right? We have seen, right? So now here, if you want to have the data of your machine, like the host machine data into the container, then whatever the data you want to copy into the container, so the data take the data from the server, means from your host machine, and copy into the volume so that that will be reflected in the container. That is one way. Right here, I don't want to go with the volumes creation. Right, I don't require the volumes right now. So that just I'm doing some kind of testing. For the testing, I require a configuration file. So the configuration file I need to copy into the container. That's it. For that, I don't require to have store the data like the configuration. I don't require to save it. For that, I don't want to create a volumes. I don't want to mount it. Something like this process I don't want to do because just a testing I want to do. So there you have an option. You have an option nothing but you can copy the data between the container and your host machine by using Docker copy command. Right? So trying to explain you guys that how many ways we can achieve this one. That is the one is the volume. The second one is the copy. Right? This is the difference between the volume and copy actually. Right. So now here I have the container something like this. So now here what I want to do, I want to copy this env.list file, some file. So this file I want to copy into this container. Right. So now Docker execute -18 and container and here I'm going to give the command called ls. Right. So here I have these many folders, directories are there inside the container. So now here I want to copy the file env list into something called OPT. I want to copy into OPT. So for that, what you are going to do here is, let's see what is the present working directory of the container slash. That is the present working directory container is slash, and in the slash you can see these are the content is present at the point of container. So out of these folders, I'm going to say directories. I want to copy this my local file, my host machine file called env.list into this OPT directory. The docker cp is the command. Copy the content which you want to copy. I want to copy the env.list file. Where you want to copy it, right? I want to copy into the container. Which container you want to copy? Because there are multiple containers are there. So if this container I want to copy, take the container ID, then colon, what is the location? Which location, right? So I want to copy into the OPT directory. where the OPT is located. The OPT is located under the slash. So slash OPT, the path. That's it. Now it is copied inside the OPT. Right. So now let's try to see whether the data is copied or not. So I will say ls/opt. So I want to execute a command ls for the OPT directory in this container. You can see env.list. The file is copied. Right. So likewise, we can copy the data between the container and your host machine. Right. So now if you want to do the vice versa, from the container I want to copy into my local. So for that, what you want to do? Simple. Just you are going to do the command docker cp, then container id colon the path, right? So where the file is located, then your host machine path. That's it. Right. So now here where the what is the container and where the file is located, and on the host machine where you want to copy it. So same thing we are going to do reverse vice versa. So likewise, the copy command can be used to copy the content between the host machine and container. So in our slide, I have explained like a process here. Copy local machine content to the Docker and vice versa. Stop the container and Docker copy source path and container ID, then colon destination path. Docker copy, then the vice versa. Then start the container and verify. Right. So this is the starting time of the Docker. So by the time when you want to do the copy stuff, the content copy, so for sure we require to stop the container. Otherwise, it's not going to allow us. But now they have updated it, right? So for now here we don't require to stop the containers. Running containers can be utilized to copy the data. That's what we have seen here. I am not stopped any containers here. The running is here, right? So earlier, right, in the previous, like in the last year, so it is mandatory stop the container. Now it's not mandatory stop and start. We can ignore this stuff, these commands. And we have some more commands to verify the our Docker containers, statistics, process information, something like that. And so here, Docker top, Docker top is the command, right? So now if I use normally top command, right, it is an interactive mode. You can see it. And in interactive mode, it is given the load average, number of users, CPU utilization, memory utilization, so much of stuff, and the process information. What are the process running, who trigger the process, what is the process ID, what is the command, like that, right? So this is what we can verify with the top command on the Linux side. So now here I will come out, then I'm going to use the same command on the container side, right? Container is also mission, Docker top, and on which mission, right? I want to verify on this container. So here is going to show you, it is not in the like live state. It will show you the information like who triggered the process, what is the process ID, what command got executed, what is the start time. Same like we are going to see. Not like the memory utilization, CPU utilization, or something like that. It's going to show you the process information. What are the process triggered, who the guy the process is triggered, and what is the process ID, something like that. Docker top. Now I want to see the utilization. These are the entry question guys for us. So I want to see the utilization, like the process utilization, memory utilization for the container, because container is also server emission. So for that we have a command called docker stats, statistics, and the container ID. Now it is an interactive mode. Yeah, right. So you are not going to see any like our menu, like the command point, CMD point. So now here you can see the name, container ID, and the CPU utilization, memory utilization, limit, network in and outs, network in and outs, like that. The utilizations, the resource utilization can be verified by using the stats command, docker stats. And I want to see the logs, right? So now here the container server. So whatever the application or whatever the process is running or the service is running, if something has happened, something is broken, I want to go and see, right? We want to see what is the issue, right? So there we record the logs. So how the container logs can be verified, right? For that, docker logs is the command. and my container ID is. So now here, this is a Ubuntu server. On the Ubuntu server, no process running, nothing is running. That is the reason we are not able to see any logs. So let me take docker run -dat-p. So here I'm trying to create a container for the Nginx, docker ps. Now we can see Nginx is running. Now I want to see the logs of this Nginx. So docker logs. This is the logs. Because Nginx is a web server. So when the web server is going to launch, what are the commands were executed in the background? Looking for such script, launching the entry point, something. So finally you can see configuration is completed and ready for the startup. The Nginx is. So likewise, the container logs can be verified with the help of docker logs is the command by followed by the container ID. Likewise, here we have one more command, nothing but the alias. Alias, right? We can create the shortcuts, right? You don't require to give the entire command, simply you can create the shortcuts. Right? So here, suppose I want to verify docker ps, right? So now here what I am going to do, so I want to see the running containers information. So right, every time docker ps, like the repeated commands, right? Most of the time, what are the commands you are going to repeat? Those commands you can create as a you can create the shortcuts. You can create the area so that it simply can you can pass the shortcuts instead of running the whole command. Right. So alias, then docker container, docker ps, dp, something, some shortcut equal to what is the command you want to give. So I want to give docker ps command. Now here simply run the dp. Okay, something is missing. Docker alias dcp equal to. Let me see. I'm going to give docker cp. Okay, I had
You
given
get
the
it.
wrong actually. Yes, yes, yeah. Alias and dp equal to docker, right? So the C is missed out here, docker ps, then dp, like that. So like that, you can create the commands, shortcuts by using alias. Kind of useful thing for us. For us, this is for us actually. Right. So then, so these are the some important commands for us and from the intro side also. And the last one is uploading our images into the Docker Hub. Right. So whatever the images we are creating, those are only to your local machine only, your workstation only, not for the other folks. Right. So now we are seeing to share the images or the contents to other folks by using the commands, nothing but the load, save, export, import. Apart from the commands, we have the third-party tools. Like from the Docker side, they are providing the Docker Hub for us. We can utilize the Docker Hub, and in the Docker Hub to the Docker Hub, we can push the images. Then other persons of your team can have the images. Right. So how we are going to push the images to the Docker Hub? Right. So for that, the prerequisite is you require an account. We require an account in the Docker Hub. So hub.docker.com is the location, the web URL for the Docker community. So go to the hub.docker.com. If you are not having an account, then create an account. Simply give the username and password. That's it. So it is going to create a repository for us. Sorry, account for us. In the account, you can create the repositories. So then under the repositories, you can push the images. So now here, I have created my account. So now I log in here. You can see RAKNS00 is my account. And here you can see some images I have uploaded here in the past, 2 years ago, 2 years ago, 2 years, something like that. Right. So now here the thing is, if you guys remember our git, the same thing like here also, right? So here when you want to store the data inside the git, so now we require a repository. We are going to create a repository. Under the repository you are going to push the data. So likewise here in our Docker Hub also, when the moment we create an account, so now here I have created an account with the name DevOps. So now here your account will be created in the Docker Hub. So then when you want to store the images, basically the purpose is pushing and pulling the images. So right, when you want to handle the images. So now here you can create repositories inside your account. So likewise, multiple repositories, like the same like our GitHub. Right, so now here I am going to create a repository called e-commerce, and here I am going to create a repository called banking. Here I am going to create a repository called retail, something like that. So now here under my account DevOps, there are 3 repositories I created. So now here, whatever the application, like suppose if I am working with the e-commerce application, now I am going to push the e-commerce application into the commerce repository, e-commerce repository, like Flipkart image, like that. So here, what are the banking application I'm working? ICICI image, like the retail, like that. So now you can segregate the things by creating the repositories. Then under the repository, you can push the corresponding images. One way. The thing is that you are not having any separate account, separate repository, something. Simply, I want to use my account only. Yes, that is also possible. You don't require to create any repositories. So when the moment you are pushing the images, suppose sample image I have pushed it. So now this image will be stored under the account, nothing but your DevOps. Now your account will be converted, nothing but it will be treated as a repository. If you are not created any repository, then your account will be treated as a repository, or else you can create your own repositories. Then inside the repositories, you can store your images likewise. So now here, you guys can observe here, RAKNS000 is my account name. I have not created any other repositories. That is the reason you can see Raknas means RAKNS000 slash my email. So it is treated as a repository now. My account will be treated as a repository. So now I want to maintain separate repositories. Then just create a repository, click on the repository, create. Now here the name, your repository name, right? So banking as an example, banking images storage repo, right? Public and private. You want to write anyone. And then here you can link with the GitHub accounts. Now I'm going to create it. Now you can see here under my account, I have a repository called banking. Right. So now going forward, when you want to push your images into the repository called banking, then you can use like RAKNS0 slash banking. Or else if you want to store the image outside of the banking, then simply can use something like that. Likewise, you can have the repositories and you can replace the repositories. Or you can have your own account as a repository. So that is fine. So now here I have an account in the GitHub, sorry, in the Docker Hub. Now under the account, I can create the repositories, or your account itself can be utilized as a repository. That is up to us. So now here I want to push my images. Right? If you want to push your images into the repository, what you need to do? Simple. You need to connect from the machine where the Docker is running. Right. So where the Docker is running from that machine, you are required to connect to the Docker Hub. Once the communication is established, then you can push or pull the images from the Docker Hub. That's it. Simple. Right. So now here, if you want to connect to the Docker Hub from the machine where the Docker is installed, right? So for that, the command will be Docker login. Docker login is the command, so that it is going to connect from your local machine to your Docker Hub. Now it is going to ask you the username. So now here my username from the Docker Hub is RAKNS000 and the password. Now you can see login is succeeded. Right, my host machine, my machine successfully connected to my Docker Hub. In the Docker Hub, my account. This is my account. Now you are connected to your account. So now you can push the images. Right. So now straight away you cannot push the images. Straight away means Docker images. I cannot push the image straight away. Then what I need to do? We need to tag it. Then we need to push it. if any image you want to push to the Docker Hub, that image has to be tagged out. Then you can push it. Right. So let's see. So Docker, I am going to clean up all the images. Right. So all the images are gone. Only one image left out. That is nothing but the Ubuntu Git image. So let me Docker this. Docker Python. Yeah. So now I don't have any images and I don't have any containers. Everything is clear. So now here just I'm going to create Docker. So now here I don't want to create the container, just a record image. Now the purpose is I want to push my image from my local machine to the Docker Hub. So for that I don't require the container, simply record an image. So for that what you can do, if you want to have only images, not the containers, then Docker pull is the command. Docker pull. Then what is the image you want? I want Nginx image. So now here the pull command just to only pull the image. It is not going to create any content for us. Right? The content will be created when you pass the command called run, Docker run. We know very well. So now here I got the image, Docker images. I got the image, right? So Docker PS, we are not going to see the containers. That is common, right? We are because I have passed the full command. So now tagging, right? So create an account in the Docker Hub, create a repository, log into the account by using CLA, then select the image from the Docker images and tag the image and push the image, right? So now here, how to tag it? So once the login is completed, then tagging the image, nothing but the tag is the command, Docker tag, right? So now here, why we require to tag it, right? So now here, when the moment I am trying to push the image from my local to the Docker Hub, right? Docker push command. When I'm trying to push, then it has to understand because the Docker Hub is a community. There multiple like huge amount of accounts are going to manage, like Shankar, Rajesh, Chris, Teja, something like that. So now here, out of all the accounts, which account it has to be connected, and under the account, if any repositories are there, and out of the repository, which repository it has to connect, then it has to push the image into that repository. Right? How the Docker will understand, how the Docker will know I have to take this image into the particular account and the particular account into the particular repository. So that's where the tagging is required. So now here we are going to tag nothing but we are going to tell the Docker to this image I want to push into so and so account or so and so repository inside the so and so account. There the tagging is required. So now here we are going to tell docker.io means the main location of the Docker Hub. So this is optional. You can give or you can ignore. So then this is my account, right? So under the Docker Hub, which account you want to connect? I want to connect to the my account RAKNS00. Inside my account, I want to push this image. If you have any repositories, then RAKNS00 slash then repository name, then slash the image name like that, right? So now here I'm going to take this one. So Docker tag. Then here my image is Nginx. Right, this is the one we have downloaded. So now here docker.io, the main URL of the hub. Then inside my account, I want to push Nginx image, some name, a new name. And if you want to tag it, you can tag it to the version. Right. So here with this name, I want to push it. With this name, I want to push it to my account tag. So now here, now in the Docker images, we are going to see two images now. The one is the one which we have pulled from the Docker Hub. The second one is just now we have tagged it with the new name. Right. So here you can see it is an optional. The Docker drive is an optional. So now you can see here the account name / the image name and the tags you can see the version. Likewise, when the moment you run the Docker tag, you are going to see the image in your image list. So now you can push it. Which one you are going to push? This one you are going to push, so that the Docker will understand, okay, this image has to push into so and so account. So now here I am going to push my image into my Docker Hub. So further the command is Docker push and the link, the path. Now nothing but the image path. Then if any versions are provided, provide the version. So now here is trying to push the image, successfully pushed out. Now go to the Docker Hub. Right, as of now nothing is there. Just refresh. Updated a minute ago. So this is what I did, Docker push. So likewise, you can push the images or you can pull the images, right? If you want to pull the images, then click on the image so that it will show you the pull command, how to pull the image. So likewise, we can maintain our own images into the Docker Hub by using the Docker login and the Docker push. Right? This is how we are going to maintain the images. Right, guys? So this is about the Docker. Any questions, any clarifications are required? Let me know. Otherwise, I'm going to start the Kubernetes. So usually, I forget to tell you, in the Docker architecture side, right, what are the components are going to involve from the Docker architecture is, sometimes people will ask. Host means our instance where the Docker is installed, right? Our AWS instance or our virtual machine, right? So now we are going to have the components called Docker daemon and the Docker engine. So Docker daemon is nothing but a kind of agent which is running in the Docker engine, Docker daemon, both will be work as a client and server fashion, client and server like mode, but both will be running in the same mission. It's not like a separate missions we are going to use, right? So everything is in the same mission. So we'll be having a components called Docker daemon, Docker engine, and the Docker CLI, and the final one is registry. It's an optional. Registry means our Docker hub where the images are going to store. So now Docker daemon, Docker engine are working as a client and server. So now the daemon is nothing but like an agent. So here what the Docker daemon will do, when the moment you are going to pass the commands to the CLI, right, the client means like you and me. When the moment you are going to pass the commands, it will be taken away the Docker daemon. If there is a connection is required with the registry, it will go and connect to the registry. And when the moment I say pull, I require the image. So now the by default images are not available, then it will go and connect to the Docker registry, Docker Hub or Nginx or whatever, wherever it may be. Who is going to take care? Everything will be taken care by the Docker daemon. So now the image will be pulled up into a local, then from the local, the images are going to convert as containers, created containers. So that's what the Docker daemon is going to do. Right. So now Docker engine is the one which is going to take care of everything in the background, like it is server. It is server for the Docker. That is what the components are for Docker from the architecture side. Right, guys? Shall we start the Kubernets?
Okay,
Sonara
Shankar.
Lera. Yeah, thank you.
Yes.
Right. Right. So now here, as of now, we have seen how to handle the code. Code means here now the application. Let's think about it as an application. Like so now here, how to handle that application which is in microservice format. Right? Microservice format are nothing but those are loosely coupled services which are not dependent on any other services. So those can be deployed individually, right? So now when I want to deploy them as individually, the guy is called Docker. The containers we are going to use the Docker containers. So those will be running as a separate servers for each service. So now here to handle that services, now we know there is a tool called Docker. The Docker will be very capable of maintaining those microservices. Right? That's what we are seeing right now. So now here, if it is a single service, then one container is sufficient. But when we are going to talk about the microservice application, means there you are going to see huge amount of services. In an application, we are going to see like 10 services or 15 services or 20 services or 50 services. We don't know, right? Based on the application. If the e-commerce applications like Flipkart, Amazon, hundreds of services will be running in the background. Yeah. If I take the banking, again, it will be running in the tens of services. Now in my project, what are the project we are working? There 15 services are there for my application. 15 services. Now each service is a microservice. Each microservice is nothing but we are going to deploy in a separate server. Each microservice is going to deploy in a separate server. And now here when I'm going to talk about separate server means is a container, lightweighted missions. Right. So now here, now the 15, suppose if I take my application as an example, now my application is having 15 services. Now the 15 services we are going to use the Docker containers to handle them. Means 15 containers are going to create in the background, and each container one service is going to handle. Means 15 for the 15 services, 15 containers are going to utilize. So now how these guys are going to communicate, because at the end the end user like you and me, we are not going to bother about what is the microservice, how they are going to couple one and each other, how they are going to communicate. Just I want to go to the application, and whatever the activity I want to perform, I'm going to perform, and I'm going to leave the application. That's it. I'm not going to bother about the background architecture, how they are going to communicate one with each other. From the front end, I should not see any lagging, I should not see any kind of problem with the application. It should be user friendly. I have to go to the application, I have to complete my task, and I have to come out like a Flipkart. Go to the Flipkart and buy the things for us, then come out from the application. But in the background, how they're going to handle, I don't bother about, right? But the background story is for us, for the DevOps folks. That's how effectively are going to maintain this application. So now here, now we know with the help of the Docker, I can handle all the 15 services. But how these guys are going to communicate one with each other? Like, so that's what we have seen in the Docker Compose. We have created the network drivers. The network drivers are going to utilize, and they're going to communicate one with each other like that with the name, right? So now here, okay, fine. So now here, okay, by using the Docker Compose, I can deploy the application, and they are going to communicate one with each other with the names, the service name, right? So now the thing is, for each service, one container I'm going to use. So now the load is increasing in my application. People are trying to hit my application, right? So now each container can capable of 10 users can be handled. As an example, each container can handle 10 users. So now here there is a service. On the service, now people are trying to hit more than 10 members. So now what will happen? The container is not enough, not capable of handle more than 10 requests. Now there the people who are trying to hit my application, they are going to see the lagging. That until unless one of the request is free, that guy, the other folks will be in the queue. So now here, once they are seeing the lagging, then obviously they are not going to impress with our application, right? Anyway, it's taking much time. So let's go to some other application. So now here we have to handle the load so that the end users are not going to see any kind of lagging from the application side. Means in the background, you need to increase the containers so that the containers can handle the load, scale up, replicate the containers. So now how we are going to replicate it? That always means you have to go, you have to be ready. Ready means you have to always monitor the containers, monitor the load. Then when the load is coming more than 10, then immediately create the replicas. No, it's not going to happen doing manually, right? So there some guy is required. A, a guy is required. He has to take care of everything for us, like this kind of examples, right? So there the orchestration tools comes into the picture, like the Docker Swarm from the Docker side. Now Kubernetes. Kubernetes is work on the Docker Swarm because he has many features than the Docker Swarm. Right. So again, it's an open source tool. Then that's the reason that the Kubernetes is very famous when compared to other orchestration tools for the microservices. Now the Kubernetes, now the tool, the guy is called Kubernetes. Now he is going to maintain the other stuff. Other stuff means handling the load. One example, right? Deploying an application that can be done with the Docker. You don't require to have a orchestration tools. But how the other stuff means, one is handling the load, And the second one is most important one is updating the versions, right? So always you are not going to run your application with single version. Right? If you are going to try to run with a single version means in the future you are going to out of the market. You are not going to add the new features into the application. Right. So now all right, you have to upgrade the applications always so that the end users are going to attract to your application. Right. So new features we are going to launch. So when the new features is going to launch to the application, then how you are going to update into the production servers, means the production application. Right. So who will take care? Again, the tool will take care. The orchestration tool will take care, updating the applications, your Kubernetes. Now something is failed when I'm trying to update the application. When I'm trying to deploy the new version, something is failed. Immediately I need to revert it. Right. Who will take care? Again, your Kubernetes will take care. Like so, not only maintain, not only deploying the application, it is going to take care many things, like the handling the load, updating, revert back, rollbacks, like that. So that's where the Kubernetes is very famous right now. Right. So now we'll see how to handle these things with the Kubernetes, deploying an application, rolling updates, revert back, auto scale, right? With the help of the Kubernetes, how we're going to handle. Right. So before understanding those concepts, we have to understand the architecture, the how the Kubernetes is going to work, how it is going to handle these kind of scenarios. Right? Very important for us. As a DevOps guys, the architecture, understanding the architecture is very important. Right? So because it is an entry area for us, and also if you understand the architecture, then working with the Kubernetes will be somewhat easy for us. Means you can troubleshoot very easily. So now let me open the architecture. Right. So before understanding the architecture, just the theoretical part, like who implemented this Kubernetes means, you know, right? The Google guys, right? Google is implemented the Kubernetes, then after that it is handed out to the open source tool. So then, what kind of language they have used? They have used a language called Golang. Golang is the one uh, it is applied to implement this Kubernetes. I think I did not mention that. So then, once the Kubernetes is given to the open source, then it is adopted by everyone. Everyone means the cloud folks, like AWS. We are going to call as a ECS. ECS means Elastic Container Service. We have a name called EKS. EKS means Elastic Kubernetes Service. CS means container, and EKS means Kubernetes Service. And from the Azure side, Azure AKS, Azure Kubernetes Service. The Google is having the Google Kubernetes Engine, GKE. Likewise, now the cloud they have adapted this Kubernetes and they have launched as a service. Right? Now we know what is service. Service means you don't require to bother about the maintenance. Everything will be taken care by the service provider. Our job is to go and utilize it, pay the rent. It means you don't require to set up the Kubernetes, you don't require to create the cluster, you don't require to set up the nodes. Everything they will take care. Your job is to deploy the application, you maintain it. That's what the service here. Right. So now they have launched their services, but these are the paid services. That is the reason they are not much popular like the Kubernetes on-premise Kubernetes, nothing but the our own Kubernetes. Because it's free, you don't require to pay anything. Here is a paid thing. And so the only difference is maintenance. You can here you don't require to maintain anything, but from our side you need to maintain everything. That's what the difference. Right. So now here the architecture of the Kubernetes. So usually, if you recall our AWS, sorry, Docker Swarm, there we are going to see manager nodes and worker nodes. Manager is nothing but a master who is going to take care of the cluster. So here, instead of manager, we are going to call it a master. We are going to call it a master. The workers and the Docker Swarm here we are going to call it nodes. So now here the technical term is master and nodes, master and slaves, master nodes. They're manager and workers. The technical term between the Swarm and the Kubernetes. So now here from the master side, we have total 4 components are there from the master side. Total 4 components from the master mission. So the one is API server, and the second one is the scheduler, and the third one is the controller, and the fourth one is the etcd. Right. So let's see what these components are going to use in the master node. So usually the API server will be the responsible person to take the request requests. Right. So now what kind of request we are going to pass? Right. So into my Kubernetes, I am going to tell deploy this application, deploy this service. It is a request for me. I'm going to send a request to deploy this service, or I'm going to send a request to scale up, increase the pod, increase the container count, or I want to send a request to upgrade the new version. Like it can be any request. So whatever the request you are passing to the Kubernetes, like the API calls, the calls will be taken care by the API server. Who is the API server? Is a component of the master node. Means master is the one who is the parent of the cluster, who is going to take care of everything, like the manager from the Docker Swarm. Okay. So now the API's calls can be your UI by using the graphical user interface or by using the command line interface, CLS or US. Either way, you're going to send a request to the Kubernetes cluster, then the request will go to the API to the API server. Right. So now here, once the request is received by the API server, then the request will be sent to the controller. So now the controller is nothing but it is going to verify the state of the cluster. The state of the cluster. So now what is the state of the cluster here is, right? Suppose this is my Kubernetes cluster, and here I have a master and I have two nodes. Now here the master is responsible of taking the load, distributing the load to the nodes, everything will be responsible to the master. So now here, right now there are two containers are running. As an example, for my one application is running, a service is running with the two containers, two copies. So now here I have a send a request of I want 3 copies. This is the request I am going to send. So now this 3 copies request will be received by API server. Then it is going to send this one to the controller. Now the controller job is to make sure that the desired state is applied or not. So actual state is 2. Actually, there are 2 copies are running. Now the desired is 3. Now who is the responsible? The responsible person is the controller. Now the controller job is to make sure the desired state, whatever the desired state we are looking for, it is applied or not. So now the controller will see verified. Okay, so there are 2 are running now. I require now they are looking for the 3. So now what it will do? It will send the request. It will go for the scheduler component. Now the request will go to the scheduler. So now what the scheduler will do? It will verify the nodes, whatever the nodes are running here. Means it's going to schedule it. It's going to schedule it to launch the new container on the nodes. Which node is available? Which node has the sufficient memory and sufficient resources are available? Then based on that, it's going to schedule the task, nothing but the creation of third replica. That will be taken care by the scheduler. Right. So now how this master will go and connect to the nodes, the communication, right? This node has to be connected and I need to deploy into the third container, or I want to connect this node and I need to replicate the third container. How it is go? How the communication is going to happen? That's what the etcd. Etcd will be nothing but is going to have the nodes information. What are the nodes are running in the cluster? The nodes information will be stored in the etcd in the form of key and values. We are not going to do anything with these components. These are the components are running in the background from the Kubernetes side to make sure everything will be working as expected. Expected means what are the requests I'm passing here, the API calls. These guys are going to run in the background. These components duty. These are the interview point for us, interview concept for us, right? So when I send a request to the Kubernetes cluster in the past AWS interview, in the Amazon, they asked me how the request will be taken care by the Kubernetes. In the background, what will happen? What is going to happen in the background when I send a request? That's what is going to happen. That's what means when the moment I send a request to the Kubernetes cluster, that will be taken care by the API server. Then based on the request, the controller will check the state of the cluster, of the current state of the cluster to the desired state. So what is the request I'm sending here? So the request is looking for some kind of state. That's what the desired state. So now it's going to check the current state. So both are matching or not. If there is a non-matching, means 3 is required, 2 are there. So now here the request will be taken care by the scheduler now. So now the scheduler job is to schedule the request. So that is going to allocate the request means the on which node it has to be allocated based on the availability of the resource of the node. So now the communication from the masters to nodes will be by using the etcd, nothing but the configuration information. The configuration information about the nodes will be stored under the etcd. These are the master node components. So now here I have explained here, guys. You can go through the critical part here. Then from the node side, we are going to have kubelet, kubeproxy, and the Docker. Right. So now here the master job is to verify the state and schedule the tasks. But who is going to create the container? At the end, we want to have a container, the third one. Who is going to do that? That's what the kubelet. Now the kubelet is an agent, is a node agent. So now here the guy job is to it always is going to monitor. Then once the tasks are coming from the master, this guy is responsible to take care of the task from the node side, like replications, creations, deployments, mountings, like anything. So what are the tasks you are passing, that will be taken care by the kubelet. He is an agent. He will always monitor the tasks and he is going to take care of the tasks from the node side. Right. So now here then kube proxy. Right. So now here now there is a there I mean to say now there are three nodes cluster as an example here. I have three nodes. One is the master and two nodes. So now here there are two containers are running here. Container 1 and container 2 on two different nodes. So now here this guy has to communicate this guy. Suppose assume it is a front end node and it is a back end node database. Now here my front end has to connect to my back end so that the data, what are the data I want to store it, I want to write it, or what I want to retrieve it. So the front end application is going to connect to the back end. So how the front end connected to the back end, how the one pod is going to communicate with the other pod, right? So that will be taken care by the kube proxy, the networking. The networking means the communication between the containers will be taken care by the kube proxy. Network rules, and so that it will be act as a network proxy, so that it is going to is going to use it for the communication between the nodes. So kube proxy is the one. Right. Then the final one is the Docker, nothing but finally what we are going to run, we are going to run the containers at the end. Right. So if you want to create the containers, obviously require the Docker. So now from the master side, the main components are API server and the controller and the scheduler, and the final one is the etcd. From the node side, we are going to have the kubelet agent and the kube proxy for the communication and the Docker for the containers. So these are the components. This is the common question for us. Every interviewer, they will ask the architecture of the Kubernetes. We have to explain these components from the Kubernetes side. Right. So now let's try to understand why the Kubernetes is famous than the Swarm. Because the Docker is the one, it came before the Kubernetes come into the picture. Now Docker introduced the Docker Swarm before the Kubernetes, but the Kubernetes has become popular. Why means the advantage here is GUI. We are not going to have any kind of GUI to maintain the Docker Swarm. Everything will be from the backend by using the CLI. But if you observe here, you can pass the instruction by using the UI, graphical user interface. Right. So here, the advantage of the Kubernetes is the Kubernetes comes with the inbuilt dashboard. There is no dashboard which makes the management complex. Right. So now here, right, if you have the GMS, easily can do the operations. CLI means you have to know the commands, otherwise you cannot. That's what the complexity. So the installation. Now, when compared to the installation from the Kubernetes and Docker Swarm side, Docker Swarm is very easy than the Kubernetes. The earlier stage, the starting time of the Kubernetes, if you want to set up the Kubernetes, there are 2 to 3 pages of 3 pages of instructions are there in the starting stage. You have to follow all the instructions, then only the Kubernetes is going to set up. Otherwise, you are going to see many issues. Even I have faced it. There are n number of instructions are there that when I'm going to start when I was start the Kubernetes, even it took me for 1 day, more than 1 day also sometimes to set up the Kubernetes. Like if you are not done properly, a single command will disturb everything. So now they made it easy. Now it is not that much of complex. They made it easy. Hardly we can set up the Kubernetes cluster with the 4 to 5 commands. That's it. It will be up and running. We'll see. So, but this is the like starting time. So starting time, this installation complex. So now the scalability, the advantage again, one of the advantages of Kubernetes is you can have 1,50,000 pods. 1,50,000 pods can be run on a Kubernetes cluster. But from the Docker Swarm, hardly you can run 30,000 containers max. Right. So here the pods we are going to call nothing but the containers are going to run inside the pods. We'll see in our setup the pods nothing but you can now you can assume these are the containers only. So 1,50,000 containers can be executed means it can be run on the Kubernetes cluster. Here hardly can use 30,000 containers. That is one of the biggest difference. So now here the load balancing both will be capable of balancing the load. It is also having the load balancing concept. It is also have the load balance concept. Both will be able to capable. So now here rollback. So now the rollback means automatically you want to revert the changes if something is failed. So that can be done with the default setup only Kubernetes. You don't require to have any specific versions. But in the Docker Swarm side, 17.0 for minimum later on, like above the 17.04 only, we have the automatic rollbacks. So it means at the starting time, we don't have the automatic rollback. After version 17.04, they have introduced the automatic rollback facility. Prior to that, we don't have. So now one more biggest advantage, right? So now they will ask usually difference between the Kubernetes Swarm and Docker. Sorry guys, Kubernetes and Docker Swarm. So you have to tell these 3 points. You don't require to tell the rollbacks and nothing. Simply tell about the GUI, tell about the scalability, how many pods can be run on the containers. Let's sorry, I mean to say on the cluster side. And the third one, you can talk about the monitoring and logging. That's it. These 3 points are sufficient. So logging and monitoring, right? Inbuilt tools are available for the pods logging and monitoring to check the health state. Here we don't have any kind of inbuilt tools on the Kubernetes Swarm side. You have to rely, you have to depend on the third-party tools if you want to help check the health state of the containers. Here we have the inbuilt tools. So now here the maximum nodes, right? Cluster in everybody is a combination of nodes, a group of nodes we are going to have in a cluster. So maximum nodes, it's suppose 5,000. Here hardly 2,000 plus only. It can support Docker Swarm, right? So the optimization, like optimize for the multiple smaller clusters, you can have a one single large cluster. Then the updates, networking availability, both will be having the same features. So there is no big difference between the updates and networking and availability. Here, the Docker daemon is connected to the overlay, right? We have seen the overlay network for the communication. Here, overlay network usual to which lets the path for the communication across the multiple nodes. Here also, QPlux is the one which is going to use for the network communication, but in the background, it is going to use the overlay network only. Both are going to use the overlay network only. Right. So now here there is a right the in place cluster updates have been consistently maturing right, so updates will be received by the Kubernetes. From the Kubernetes side you can update like easily. Here cluster can be upgraded in place, right? So like the frequency of upgrades can be vary between the Docker Swarm and the Kubernetes. And the high availability, right? So here high availability health checks performed directly on the pods, right? Because inbuilt tools are available. However, contents are restarted on a new host if a host failures are encountered. Right. So high availability means, right, we have seen if some node is down, automatically the load will be distributed to the other nodes. That's what the high availability from the front side. Here you can check the states and you can restart it automatically from the global side. So right, so here the major difference which you need to focus when the people are asking about the difference between the Swarm and the Kubernetes, you focus on the GA stuff, focus on the scalability of the containers, and tell them about the logging and monitoring, and you can tell the node support. These four are efficient enough. You don't require to remember all these options. Right guys, so here in this PPT we'll see the different ways of installations. So earlier days, I used to tell the Kubernetes setup on the Google side actually by using the GKE, Google Kubernetes engine. So now, but the later on, we have faced a problem like the utilization. Right, so here they will provide 300 free credits, like our AWS 12 months of with the 750 hours. Here the credits are going to provide. So now here the problem which we have faced is one of the student by he forgot to remove the cluster. So at the end of 2 months or 3 months, I don't know exactly what time it is, he received a 15,000 of bill. He received a bill and automatically the 15,000 is deducted from the credit card. He have provided the credit card information. Automatically they have deducted the 15,000 because he forgot to delete the components. So then again, like he came to me, then I asked him to raise a ticket and tell them like I am a student, just for practice purpose I have created, but I don't know about this billing and all stuff. So he raised a ticket, then he followed the team, then finally he said like I'm a student, the same story he explained to them, then finally they have refunded them. But everyone, the case will not be for this everyone, right? So there is a chance of they are not going to refund it. So that is the reason we are going to skip this Google setup. Right, so we'll go to the our AWS setup only. So earlier, like usually I used to explain the this Chrome setup on the Google, but with this issue, I have skipped it. So you can skip this part. So here from the 31 slide, we can see the Kubernetes setup. Right. So this is complex setup. This is the setup from the Kubernetes side, the complex setup. So like you need to run all the setup. Then we have minimized. We have minimized the setup by using the second one. So this is the easiest setup for us actually. AWS 2 I have given. This is from the 44 slide. So here this is hardly that's it. Hardly 4 to 5 pages. Right. So guys, so we'll go with the setup. So setup is the same. We require the cluster at the end. So either you are going to set up with the complex one or you are going to go with the easiest one. Finally require the cluster. But we are going to use the pure admin setup here. We are not going to use using any services. So we are taking in instances from the AWS or a virtual machines. You can take it on the machines. We are going to set up the Kubernetes cluster, like the Docker form. How we are set up the Docker form. The same way we are going to set up the Kubernetes. Right. So let's go with the second setup. It will be easy for us. Right. So before setting this cluster, let's take a 15 minutes break now, and then we'll come back and we'll see the installation, then followed by our Kubernetes concepts. Okay. Right, guys. So 12:40 will meet at 12:55.
Okay, sure.
This conference will now be recorded.
Okay. So cluster setup, Kubernetes cluster setup. Like the cluster is same like our data form only, but the installations, the commands are going to vary. Right. So here the requirement, if you want to have a Kubernetes cluster, the minimum requirement here is Ubuntu 18 series, and we require two CPUs, 2 GB RAM, and hard disk 8 GB is sufficient. So now here, this is required for the master. For the nodes, we can take T2 micro. That will be fine, no issues. Right. So now here, we require at least for a master, two CPU and 2 GB of RAM is required, like of Kubernetes, like of Sonaki. Right. So let's go and set up. So we will be having the official documentation from the Kubernetes. So we can get that one also. Kubernets installation. Kubernets.io is the site. This is the complete tutorial of the Kubernets. You can find. And the installation also you can get it from here. Straight away you can get the link. So that's what I'm looking to install and setup. So this is the one. Tasks, tools, then install here. Install setup. So this is the installation process. Installing the Kubernetes native package, Ubuntu Debian or iPod or CentOS or HL Pro. Right, you can find this instructions to set up the Kubernetes. Right. So I have given the installation instructions here in our PPT, so you can follow the same here. So what we have done here is, so whatever the commands are there to set up this Kubernetes cluster, these commands for the Windows, right? So for the CentOS and Ubuntu, this is the one. So these commands we have placed in a repository. So you go to this particular repository. Repository. So here we have a script called initial.sh, and this script you can observe here. So whatever the commands, the instructions which the Kubernetes documentation kube.io is provided, the same instead of running individually, we have placed in a file. The file is nothing but our shell script .sh. So now these are the nothing but the same steps only, the same instructions only. So then this script we are going to execute so that it can minimize our time, and also there is a chance of spelling mistakes or something, right? You can avoid all the stuff, right? So the instructions we are taken from the community document and placed in this file. Nothing but the file is nothing but a shell script. Then the script we are going to execute directly so that we are going to save the time. That's what we have done. So now here, this script, the shell script, we are going to execute where, right? Where we are going to execute. There are multiple ways. The one is you can have a server, you can have a machine, something like this. And once the machine is created, then connect to the machine and start execute the script so that the commands, the instructions, whatever there in script that will be executed on the server. That is one way. The second way is we are going to call as a bootable scripts. Bootable, right? So bootable means booting time. When the server is going to boot, when the server is going to start, at that time this script is going to execute in the background. You don't require to run in the foreground, like create a server, connect to the server, and execute it. While the server is going to launch, with the launching, you can execute. That's what we are going to call as a bootable scripts. So now pass this shell script as a bootable script while creating the server. That is second way. Multiple ways you can do that, right? So we'll see the easiest way, nothing but passing as a bootable script instead of connect and execute. Okay, and so here I am going to take 3 servers. So we are going to create a 3 cluster node like the Docker Swarm. Right. So for that, I am going to take 3 missions here. So the instructions we are going to follow for the Ubuntu. So I am going to take the Ubuntu Yeah, 8.04. Select. So here for the master, we require at least 2 CPU, right? So here I'm going to take 2 CPU RAM, 2 GB RAM, right? So minimum means 2 for T2 medium. So I'm going to take the T2 medium and the configuration, right? So here, go to the configuration step here. So earlier we used to take the MN and directly straight away will go to the review and launch. So now here I'm going to go to the configuration step here. So number of instances I'm going to ask three missions I'm looking for. Then scroll down here. So scroll down. There is a section called advanced details. As of now, try to remember this one. We'll see anyway in the AWS side. So here you can see there is advanced details and expand it. So there you can see user data is an option. Right. So user data is an option. There you can see a box. And inside this box, just copy the line of code. So here, this one. So copy from here, copy, copy and paste. Then go here and paste it here. These commands are mandatory commands to set up the cluster. Right, you can go to the script and you can verify the commands, what are the commands are there. So these commands are required on all the nodes. Like whatever the nodes you are going to take as part of the cluster, in all the nodes, these commands should be executed. So that is the reason straight away I'm passing by the bootable script to all the three missions. So now I don't require to pass it individually one by one. It's saving of my time. That's it. So then this is the one which is required. Pass the script and give the count as 3. Once this is done, now you can go to the site aware event launch and you can launch it. Now 3 missions are going to launch and 3 missions will be executed the portable script. So now here give some name here. I'm going to give for one node I'm going to give the name called master, and the second node I'm going to give as a node 1 for either, right, for identification. That's it. So node 1, node 2. So now let's try to connect to the master node first. I can see it is running here, but still the connect option not available. Still it is in the process. Connect, copy. Yes. This is my master node. So now here, let's go to the PPT. Like so once nodes are ready, your cluster nodes, then we require to run the below command. Cube admin initialization. There is the cube admin here. Right. So if you remember the Docker swarm, there is a Docker swarm initialization. So that we are going to tell make this machine as a manager. Right? Make this particular machine as a manager. Oh, so in the same fashion here, out of all the three, which one you want to make it as a master? Right? That node IP has to be provided for the command called kubedmin initialization. Like the swarm initialization here, kubedmin initialization. That's it. So now here, take that command here and replace the IP. Kubernetes installation pod network field. Pod network field means whatever the containers are going to create inside that cluster, so those will be allocated with this network only, under this network only. So here I'm taking my external IP. So usually it should be actually you'll take the VPC IP, but anyway that is fine. So let's take the master IP. So take the command, copy, and go to the master. So this is the master machine. So on the master I'm going to run this command so that it will be executed as a master here. So here it is showing some error for us. Unsupported kernel release, ignore, apply errors. So here while passing this command, we need to run the ignore perfect errors. Not found. So not found. Here, something has to be covered here. One second, guys. I think this is the one. Go to use all. I think it's working. I will update this one in the slide. So we need to provide the option ignore perfect all errors are. Here the setup is ready. From the master side, the initialization you can see your Kubernetes master has initialized successfully. So now here to start using the cluster, you need to run the following as a regular user. So the permissions you need to provide for the user. So to provide the permissions, this is the step, these steps you need to require to run. This is one thing. After the cluster is master is ready, then this command has to be executed for the permission sake. And for the nodes, this command has to be executed. If you remember, right? So the Docker form also said once the swarm is initialized, so there on the node you need to go and run the token ID. Same like here also. This token has to be executed on the each node so that nodes will be connected to the master. Right? So we have extra one more step for the permission here. Right. So let's go to the slide again. So here in the slide, this is done. Then right, the permission stuff. Right. So here, simply go here. Right. So here, what we are trying to do here is under the home directory, we are trying to create a hidden directory called cube. Cube will be created. Then here we are going to copy it. We are trying to copy the configuration file, admin configuration file, into the user who is trying to perform the operations. Here I am taking the root. You can take your name, your account. Whoever wants to perform the operations on the Kubernetes cluster, that guy requires the permissions. How you will get the permissions? The config file. This file. Right. So now when the moment you copy the config file into the particular user account, inside the user account into this directory, so now the user will take the config file and you can perform the operations. Like any user you can take, any user. The user, if the user wants to perform the operation means that guy required this configuration file. So that's what the step is here. So now here I'm going to copy the file. Then permissions. Permissions we are going to give to the configuration file. So changing the ownership. So let's see here, ls-a. Now you can see there is a .cube directory. Go to the cube. There you can find the config file, cat config. So now this is the keys. We are going to see the keys to connect your master to slave, the key information. Right. So cluster and the cluster key, the certificate, and our cluster. Right. This is the IP or master IP, and this is the port number to connect to the cluster. 6443 is the port to connect to the cluster. And this is the admin, the user, right? We are trying to connect to the cluster. This is the user certificate, like that. And we'll be having the client certificate to connect to the clients, client key data, to master and clients. So this is the background story of the our Kubernetes. So here, the concept here is this config file is required. The config file means the admin configuration file is required the user so that this user can perform the operations on the cluster. The user can be anyone, not like the root. You can take any user. Right? So now then, so once this setup is done, just verify whether the Kubernetes is properly configured or not. So for that, kubectl version is the command. If I run the kubectl, the version information has to be provided here so that you can confirm the Kubernetes setup is done properly. So now here kubectl is a tool which is trying to pass the instructions to the cluster. Like if the architecture, if you remember the architecture, sending the instructions by using the GUI like UA or the CLI. Now, if you want to send the instructions through CLI, there the tool we are going to use is the kubectl. Kubectl is the tool we are going to use to pass the instructions. So now the kubectl is ready. So then run the below commands to configure the network, right? So the communication between the pods, further the network is required. So the network setup can be done by running these below commands. So run the first one, export, and then run the second command. So now here wavenet is the network we are going to use. You means the cluster is going to use for the communication. So now wavenets are created. Means in the background, what is going to do here is going to create containers. So everything will be executed with the help of the containers only. The containers here we are going to call the pods actually. So now the pods are going to create. Now the pods are going to utilize for the cluster management, cluster maintenance. So when the moment it say wavenet are created means in the background the pods are created, the containers are created. I will show you. I will show you everything. So now here this setup is done. As I said, the Kubernetes is having an advantage. Nothing but it is going to have a dashboard GUI to maintain your cluster. Cluster can be maintained with the help of CLI and the GUI. When it comes to the Docker Swarm, we don't have this facility. Right? So now to set up the GUI dashboard, just execute this command. Now you can see the dashboard is created. Right, whatever the dependencies, whatever the components are required for the dashboard, it will take it automatically. So you don't need to bother about it. So now the dashboard is ready. Now if you want to see the dashboard, right? So take the node and followed by the port number. By default, the port number will be 31,000. 31,000 is the port number. So let's go to your cluster and go to the security group, right? Since the security group by default is 22. So go to the inbound rules and add a rule here. So I'm going to make it all traffic anywhere. So now go to the dashboard again, go to the instances, select the master, take the master IP and run colon 31,000. If everything goes fine, we should see the dashboard, the Kubernetes dashboard, right? So yes, everything is fine, right? The dashboard is ready, Kubernetes. These are the components, right? So now here the dashboard is ready. Then go to, so let's see how the dashboard will be visible here. So now here the worker setup, right? So now here the master is ready. The required components, the networking components, the dashboard components I have installed on the master node. So now here I need to connect my nodes, whatever the nodes I want to use in my cluster, those nodes has to be connected to the master, correct? So for that we require to run the token join command like the Docker swarm, so that the nodes will be connected, right? So here the cluster information, if you want to see the cluster versions and everything, then this is the command kubectl, right? As I said, kubectl is the tool to execute the Kubernetes commands. Now kubectl cluster info, so that you can see master is running with the so and so port, with the so and so IP, domain name DNS is running with the same here, and this, right? So like master and domain, as of now we don't see any nodes here actually, right? So now let's try to connect the nodes and see. So now to connect the nodes, right, I require the join command, right? I require the join command to connect to the nodes. If I go back here, I can see this is the join command. Simply what you do, you need to take this join command, go to the node and run this command. That's it, right? So now if you missed out this join command, you can get the join command again by executing this command. Token create print join command. Right? If you missed out the command, so you can get it back by running this token command. So go to take the token command, and if you run it here, the same command, the same join command you can get here. Right? If you miss it out. So then go to the AWS and let me connect to the node 1 here. Take the node 1 communications, the connectivity string, copy, and I'm going to create one more window. Then right, so let me switch as a root. So now here I'm going to take this command, join command, and go to the node, save once, enter. Backslash in the same thing here. This node has joined to the cluster. Right? So likewise, we can go to the other node as well. Right? So go to the other node, take the connectivity string, and open one more window. Right, so here I'm going to take the join command again, copy, this node is join the cluster. So now it is going to give a suggestion. If you want to verify the information, you can run the kubectl get nodes. Where? On the master. Like the Docker form. Every operation should be from the master only, not on the nodes. So now go to the master. So this is my master, and kubectl get nodes is the command to get the nodes information. Right now you can see all are in ready state, and this is the version of my Kubernetes, and this is the master node. Right. So now your cluster is ready. Now you can start working with the cluster. We have the master and we have the two slaves, right? So let's see here, simple, right? So hardly we have executed 4 to 5 steps. That's it. So now earlier this, but it's a complex setup. If you go to the previous setup here, right? This is the one which is a complex setup. We set up the Kubernetes. You don't require to do all things. Simply can go with the latest. Right. So now here, once your cluster is ready, then start working with the cluster. Right. So now go to the cluster. So now to get the nodes information, kubectl get nodes. Now you want to see each node properties, the complete node information, right? So if you guys remember, Ansible setup is the module which will provide you all the properties. If you take the Docker, inspect is the command, Docker inspect, it will give you all the properties of the container. So now in the Kubernetes, kubectl describe is the command. You have to remember kubectl is the one which is going to use to perform the operation on the cluster. Kubectl is the one means kubectl is a tool. Right, not kubectl describe. Then which node you want to see? Suppose I want to see this node information. So, right, so here is not able to understand what exactly this one. So here we need to provide it's a node, kubectl describe node, and the node IP. Kubectl describe node and the node information. Right, so here you can see the complete information about the node, right? Node IP name, roles, labels, annotations, chains, unschedulable, something like whatever the default configuration is there for the particular cluster. So the default information you're going to find it here. How long from it is running, and this is the namespace actually. Cube system. I will show you. So then the CPU, memory utilization, and the kubelet. Right? Kubelet is nothing but your node component. Right? So the node component is a kubelet. Kubelet is an agent to work with your right. So likewise, if you want to see the node properties, node means the server properties, then kubectl describe node and the node IP. Any node you can verify. Right. So now how this Kubernetes will maintain the services. Right. What is the purpose of Kubernetes? Kubernetes purpose is the orchestration tool to manage our microservices. So now here how the services are going to maintain in the form of containers. So now in the Kubernetes world, we are going to call the containers as the pods. Pod. And so now here the pod is nothing but here. If I take the architecture again, my master and these are the two nodes. So now here, what the cluster is going to do here is going to create a pod. The nodes, the pods are going to create. So now each pod can have a single container, or it can have multiple containers also. That's why the technical term given as a pod instead of the containers, because the pod is not a container. The pod is a holder. This guy is a holder for to what? To hold the containers. So now the pod can have a single container. The pod can have multiple containers. You can have multiple containers also in the pod. But in the real time, the best practice always you are going to have only one pod, because you cannot launch a pod with the same port and a container with the same port inside a pod. Now pod is a kind of box, and the box if you want to launch, the containers with the port 8080. No, it is not going to allow because it's going to use the same networking, the pod. So inside a single network, you cannot launch the same ports. That's what the conflict. Right. So you require to launch the pods with different ports. Then you cannot. Now the accessibility will be the difficult for us. Like now you need to tell which pod, which container you want to connect. Port 80 container, port 81 container. So that's why we have some kind of problems to launch multiple containers in a pod. That is the reason in the real time we are going to launch only one container in a pod actually. But yes, the pod can have a capacity of it can have multiple containers also in the pod. Right. So now here we are going to call as a pods in the cluster. Now the pod is going to hold the containers. Fine. So now here where these pods are going to create. Right. So where these pods are going to create means like the locations. Right. So now here the cluster will be having a concept called namespaces. So now here suppose this is my node. This is my cluster. So now here I am going to create namespaces. Like that. Right. So now here, if suppose if I'm going to treat this as a cluster, right? So now the cluster, what the cluster is? Cluster is a combination of nodes. So now I'm not going to represent the nodes here. So let's try to assume this is a cluster. So in the cluster, I can maintain my containers. My container means here the technical term is the pods. I can maintain my pods in a separate spaces instead of placing all the containers in a single place. I'm going to maintain the separate space so that I can provide access to the people for the required parts only, not the everyone. Right. So what the required here? The required here is nothing but the DBs. DB should not be exposed to the everyone. It is going to have the sensitive data. So now here, whatever the containers I am going to containers here, the parts. What are the parts we are going to launch in this particular namespace? We are not going to give any access to the people to this area. This base will be private. Right. So whatever the containers I'm launching in the back end, so these guys also not required to give the access because these guys are going to execute the logics. So I'm not going to give any access. Front end, the UA, the application front end UA. Yes, I'm going to provide the access for the parts. Likewise, if I place everything in a single space, then you cannot maintain this as a private. That is the reason you require to have a segregation. So if I have the segregation so that the particular block I can provide the access, only this particular block, not the other blocks. So now the other blocks means the spaces. We are going to create a private spaces. Those spaces we are going to call as a namespace in the cluster. Namespaces. So nothing but we are going to create a separate space. In the space you are going to launch your stuff. Stuff means your containers, nothing but the parts. Then you can utilize it. Likewise, Kubernets will be having the namespaces. In the namespaces, the containers are going to launch. Now the containers means the parts. The parts are going to launch. Right. So now here, suppose I am not providing any namespace here. So I did not provide any namespace. Then what? Then what will happen? Usually the default. If you are not providing any namespace means automatically the cluster will take the default namespace into the namespace. Whatever the containers means the parts you are going to create, it will be launched. The default namespace. Right. So now here, let's go and see how many namespaces are there as a default. Right. So now here I'm not going to create any namespace like front and back and DPA something some XYZ. Right. I want to see the existing like whatever the namespace are created with the installation. Right. I want to see that namespace information. For that, kubectl get ns. NS means namespace. Right. So now here you can see there are three namespaces we got with the installation. One is the default, the second one is the queue public, and the third one is the cube system. This is also an entry question for us. What are the namespaces you are going to get as a default when you set up the cluster? Default, queue public, cube system. Right. So now as I said, each namespace will be having the parts that you can deploy or is going to have the container. Now I want to see the containers, the parts information to the respective namespace. Right. So now here I want to see what are the parts are created into the particular namespace called default. Right. So now here to see the containers information. Now the containers are nothing but the parts. The parts information in the cluster, the command will be kubectl get parts. This is the command to see the containers information. No resources are found. So what happened here? Right. So what happened here is simple. So here I am not mentioned any namespace particularly, so that my kubectl will go and see the container information into the namespace. When I don't mention any namespace, by default the system, the Kubernetes cluster will go to the default namespace. Right, nothing but this one. It will go to the default namespace and it will go to and fetch for the containers, the parts information. So as of now, I have not deployed any parts. That is the reason we are not going to see any parts information here. But if you remember, when the installation, right, at the time of installation, we can observe the when I'm trying to set up the dashboard, I can see the dashboard is created. Some components you can observe like the components are created. Likewise, we have observed while setting up the queue proxy, right? The networking. There also we have found the wavenet is created. Wavenet means that, as I said there, these created means the parts are going to create in the background. Right. So now where the parts are getting created, right? Right. Now those will be go to the other namespaces which are going to maintain by the cluster, not by you and me. These namespace will be for us. Whatever the parts you are going to deploy, that will go to the default namespace for us. These two namespaces will be for the Kubernetes cluster to maintain their master component resources and the nodes components resources. Right? etcd, controller, scheduler, those areas will be maintained with this namespace. Right. So now I want to see the parts. Like as I said, the parts are getting created under the namespace. Right? Let's go and see what kind of parts are created. Right. If you want to see the containers, nothing but the parts information under a specific namespace, then the command will be kubectl get parts. Then we require to provide the namespace information. To provide the namespace information, -n. -n is nothing but the namespace. Then give the namespace name. Right, so by default, queue public is also not deployed anything. That it is by default means as of now, no specific pod is deployed into the queue public. Now I'm going to repeat the command again. Then here I'm going to use the other one called queue system. Now we can observe. Right. So these are the pods are created in the background. When I'm trying to install, I mean to say when I'm trying to set up the cluster. You can observe here wavenet, the networking. Right. Why there are three wavenets? Right. Why there are three means three containers. Right? Three containers are created, three pods are created. Why three pods are created means your communication, your parts communication between the nodes. How many nodes are there in the cluster? There are three nodes are there in the cluster, one master and two nodes. So now each and every node should have the communication. Otherwise, you are not going to see the proper communication. Right. So now whatever the parts we are going to deploy, that will be distributed among the three nodes. Right. So when the parts are distributed among the three nodes, they have to have their communication. Otherwise, the application is not going to respond properly. So who will take care? The network, your proxy. Right. So this is the case. So now that is the reason a container, a pod is going to deploy into each and every node of the cluster. Now here the three nodes means three pods you are going to see here. Likewise, the proxy also. the proxy also, right? So each and every node you require the proxy for the communication, networking, this one, and for the communication queue proxy, right? So now you can, if you observe, I said kubelet, queue proxy, docker are the node components. For the master, I said etcd, controller, scheduler, APS server. But why the proxy is created on the master also? Because I said it's a node component. Yes, but the if I'm not going to have the proxy on my master, then how the master is going to go and take the parts information from the nodes, right? Because every operation we are going to perform from the master. If I want to see the health state of the part, I will go and run the command. So now how, if I don't have the communication, then how am I going to get the information? That is the reason the proxy also need to be deployed on the master node also. Otherwise, we are not going to have the communication from the master to nodes. That's for the queue. That is the reason for the proxy and for the networking we are going to see three. Now the DNS. So now the DNS is nothing but, right? So when the pods are going to create, so that the pods will be allocated with the domain names, right, the IP allocation. So now the IP allocation and domain names will be taken care of by the core DNS in the background. For each node one DNS, that is the reason on the node these DNS are going to deploy. Right? Because the pods are going to create now you can think about it. The pods are going to create only on the nodes, not on the master. That is the reason only we are going to see two DNS. Right? So when the pods are going to create, for the pod only we require the DNS. Pod means the containers, the new containers. Those guys are require the IPs and the DNS. So where the pods are going to create means on the DNS, on the nodes. That's the reason you can see only the two pods. So this is the etcd, the master component, API server, the master component, controller, the master component, scheduler, the master component. For each, right, on the master 4, and dashboard, right, the GUI part. So now these are the pods are created in the background, nothing but on the cluster side, right? So about our architecture, and these are the components. Now going forward, when I'm going to launch any pods, those will be go to the my default namespace called default, or you can create your own namespace and you can deploy the pods into the namespace. Let's see. So let's see both. Like if I'm not having a namespace, like where it will go. Now after creation of the namespace, how we are going to deploy the pod to the namespace. Right. So let me. So now here I am going to deploy my Nginx server. I want to deploy the Nginx server into my Kubernetes cluster. Right. So to deploy the Nginx server, now the server means the container again. So now here when I want to deploy a container of Nginx, so now this is the command kubectl run. Right, the same like Docker run, nothing but to create a container. So now what you want to create? I want to create the Nginx container. This is the name. Input, right? Image, hyphen image, nothing but which image you are going to pass as input. My Nginx image. Docker run, and the image name we are going to provide here. The same kubectl run. Here we are going to pass extra option called hyphen image, so that you will understand. Okay, this is the image I need to pick up. So now here you can see the Nginx is created. Yeah, nothing but the pod is created. So now as I said, so the pods are going to create under a namespace, not the particular namespace, under a namespace. So if I don't mention namespace, it will go to the default namespace. Right. So now kubectl kubectl. Now to see the pods information, the command will be the kubectl get pods. Who should be familiar with this command says. It is required for that actually. So now here you can see when I say kubectl get pods, then you can see there is a pod name nginx with some ID. Automatically it's going to attach. Then you're going to say I requested for one pod. Out of one pod is running. You can see the status running. 75 seconds, the age, that lifetime of the pod. The container, remember the container. Right. So here you can see that the nginx is running where? Where means the namespace. It is running in the default namespace called default. So kubectl is happening here. Kubectl get pods -n default. Right. So if you want to see the particular namespace parts, then you can provide the namespace information. As I said, right? So here now it is confirmed like this is running in the default namespace. Right. So now here is a container. The pod is nothing but the pod is holding a container. So now here this is my server, a lightweight server container. Now I want to see my pod information, the properties. Right. If you remember, if you want to see the properties of a node, kubectl describe node and followed by the node IP. If you want to see the properties of a pod, then kubectl, the same command, kubectl describe. Which you want to describe? I want to describe the pod. Earlier it was node, now I want to describe the pod. So what is the pod name here? Take the pod name and enter. Right. So now you can see here the pod information. Here also you can find where exactly the pod is deployed. Default namespace. Right. Like where the node IP. Right. So now here there are two nodes in my cluster. On which node it got deployed. Right. So if I go to my cluster, this is 17 and this is 182. So now if I go here, you can see 182. Right. I am not mentioning anything. Right. Simply my cluster is taken care where it has to be deployed. So now the label, right? So now pod name is nginx and the IP address, the pod IP address 10.44.0.1 and the container ID, right? So this is at the end with the container. The container is created. So likewise, you can see here the process, right? So pulling the image of nginx successfully pulled and create the container. Right. If something is failed, your pod is not deployed properly, then by using that kubectl display pod, so that you can find the information here. So if anything failed, then you can see the information here, so that you can understand. Okay, this is somewhat is failing. Then you can go and rectify it, and then you can solve it. Right. So this is one thing to see the parts information kubectl describe the part. Right. So now the advantage with the Kubernetes cluster. Right, the advantage with the clustering tools, the orchestration tool like the Swan and Kubernets. Right. So now that we'll see. So kubectl. Now I'm trying to delete this part. I'm trying to delete this part. Right. So if you want to delete this part, what will happen? Right. You are going to lose your application. Simple. Right. Now my application is running on my here. Suppose on the nginx. Now if the pod is deleted, means the content is deleted. Wherever the application is running, if the server is gone, then obviously you're not going to see. You're not able to access your application. Right, let's see. So now to delete a pod, kubectl delete is the command. Then pod, then the pod name. So now the application will not be reachable because the pod is gone. Right. So now I'm going. Let's see. Kubectl get pods. I have the container. Right. So now here then the pod name got changed. 48 and 260. That's what the orchestration tool advantage. Right. You don't bother. You don't worry about it. You don't worry about your application. If something is something, if some reason, if your parts are deleted, automatically your parts will be created by the cluster. Right? So that's where here I ask you for one replica. So now when I say one replica means always it is going to maintain the one replica. That's what the desired state with the current state. So now my desired state will be always one, right? So the current state is one. Yes, the desired state both are matching, no action. Now the current state become a zero when I did the part. Now the desired state is one. So automatically take an action. Who will take care of this one? Controller. From the master components, the controller is the one. Always the guy responsibility is check the desired state with the current state. If anything is not matching, then immediately take an action. Who is taking action? Scheduler. Now the scheduler will take an action. Who will take care of the creation of the parts? The kubelet of the nodes. That is the link actually, right? So now here, so when the if some reasons the parts are deleted, automatically that will be created by your cluster. This is one of the advantage. So now here kubectl, there is a command called get all. So now here get all means there are certain components are going to be created when you deploy a container, means a pod in the cluster. Certain components are going to create. So what are the components are created? I want to see. So those information you can find with the command called kubectl get all. Enter. Now you can see here a pod, correct? So that's what we are observing here. Right? I said certain components. So the first component is a pod is created. Fine. Then a service is created. I did not mention like I never ever mentioned like I want a service. What is service? We'll discuss about the service. Very, very important concept of the Kubernetes. We'll see. So now I did not mention, but in the background the service is created. For whom? For the guy called this Nginx. And one more object is created deployment. Right in the background. I did not mention to create a deployment. Still it's created for me. And one more component is created replica set. That's what the desired state. That's what the desired state. That when I delete the pod, my desired state is one. My current state becomes zero. Both are not matching. Then immediately create a container. That's who will take care. Your replica with the help of the replica set, your control manager will be taken care. Right. So now here, if you want to see the particular objects information, right? If you want to see the pod information, what I did, kubectl describe. To see the information, describe is the command. Kubectl describe pod to see the pod. Likewise, if you want to see the service information, right? So now kubectl describe service. Right? Either you can remove this one or you can remove this one. We don't require to mention two. So kubectl describe. I'm going to remove this one. This is the service information. Where the service is deployed, namespace default. Here the selector, IP, port, target port, we'll discuss. Will discuss at the time of service section. Let's try to understand. Endpoints. That is but where how to connect this one. Likewise, if you want to see the deployment details, kubectl describe deployment details. So what is the name here? Nginx is the deployment name, and the namespace again is the default, and the labels are nothing but the name of the deployment is Nginx. And here you can see rolling update strategy. We'll see this one now in the deployment strategy. So strategy type is rolling update, and here you can see the container information. So right, so in the by default is a pod. In the pod, the containers are going to create. What is the container created? Nginx template. So for the Nginx, what is the image we have used? Nginx is the image we have used. Right. So now at the end you can see, right. So here the scaling the replica set, scaled up replicas. Replicas means one. I'm looking for the one. That is got created. So likewise, kubectl get all, you want to see the replicas information, kubectl describe, and you can provide the replica. You can see the replicas information like that. Right. So here, that current is 1 and desired is 1. So in the replicas. So now here, if you want to see any component, any object information, that describe is the command. Kubectl describe, then provide the pod. If it is the pod, provide the pod name. If it is a disk, if it is a service, provide the service name. If it is a deployment, provide the deployment name. If it is a replica set, provide the replica set name. That if you want to see all together, kubectl get all is the command. If you want to see only the deployment information, if you want to see only the service information, if you want to see only the replicas information, not all together, yes, it is possible. So kubectl get service, only the service information you can find. If you want to see kubectl get deployment objects information, nginx. If you want to see only the replica set, rs. Likewise, individually can get the informations, or all together, kubectl get all. These are the shortcuts. These are some useful commands for us. In day to day, we are going to deal with these commands actually. Right. So now we know, we have seen how to create a pod to the default namespace. Right. So now once I created a pod, what are the objects or the components are created in the background? Right. And we have seen the desired states and current states, how those are going to maintain in the Kubernetes cluster, how it is going to maintain. And also we have seen how to see the information about each and every object, nothing but the service, deployment, replica set. Now we'll see how to create our own namespace, then how to deploy the pod into that namespace, not into the default. Right. So now here, as of now, if I don't mention namespace, it will go to the default. Now I want to have my pods should be running in my namespace, not in the default. So for that, we have to have our own namespace. kubectl create is the command. What you want to create? I want to create namespace, ns. Right. So now here, now give a name. Right. So here I am going to give the name called dev env. Enter. Now here you can see the namespace called dev env is created. Now kubectl. Now we know what is the command to see all the namespace information. Get ns. Now our environment also ready. Our namespace is also ready. Right. So now if you want to deploy the container, nothing but the pod into your namespace, then while deploying, you have to provide what you want to provide. You have to provide the namespace. Right. So now here right. Let's take the same deployment command. Kubectl run. Right. If I don't mention any namespace, it will go to the default. Now you need to provide the namespace detail so that it will go to the particular namespace. Right. So kubectl run nginx --- image nginx. Then where you want to deploy? I want to deploy into my namespace called dev env -n, nothing but namespace. And what is the namespace? Dev env. Now you can see nginx is created. Now if I see kubectl get pods, we are going to see only one, that is under the namespace called default. Correct. So now I want to see my pod information which is deployed under the namespace called dev env, nothing but my own namespace. So for that, kubectl get pods where -n, my namespace is called dev env. Yes, perfect. Now the pods are running in different namespaces. Right. So likewise, we can have our own namespaces and we can create the pods, means we can deploy the pods into our namespaces. Right. So in our real time, the namespace where we are going to use, like I have given the example of, I want to have the DBs in the separate namespace, and I want to have the my APIs, my front end into separate namespace. There we can use, or also sometimes to to have the budget, to maintain the budget, to effective maintenance of the budget. What we are going to do? Suppose I require the dev environment, QA environment, user acceptance testing, UAT environment, and production environment. Right. So now here, if I want to have 4 environments, means each environment will be having at least 3 nodes. Minimum for the minimum cluster, we require 3 nodes, one master and 2 nodes. Right? If I want to maintain 4 environments, means I have required 4 into 3. 12 servers are required for each environment. 3 nodes, 3 nodes, 3 nodes. Right. So now here it's now the budget constraint. Right. So if I am going to run 12 nodes 24/7 means the bill will be somewhat huge. So now the client is not happy with that actually. He don't want to spend that much of amount to maintain the environment. Then what we can do, instead of having 4 separate clusters, 4 into 3, 4 separate clusters, we can have a good cluster means with good configuration. With good configuration cluster, with the 3 nodes, we can create the 3 nodes cluster with somewhat good configuration. Then the cluster can be have different namespaces. We can have create a different namespace like this, dev environment, QA environment, like that. So now, if you want to maintain the dev cluster, just deploy your pods into the dev namespace. Then, if you want to maintain the QA environment, just deploy the pods into the QA namespace. Now, yes, one cluster can be utilized for to maintain 2 different environments like dev and QA. So now we are going to have the dev namespace endpoint. That endpoint will be given to the developers so that they are going to connect to the dev namespace and parts. Now for the testing, you are going to give the QA namespace endpoints so that they will connect to the QA namespace parts. Likewise, we can maintain the environments in a single cluster instead of having multiple clusters. Likewise, the namespace can be used in multiple ways. Like I said, front and back ends can be segregated like this with the namespace, or you can the environments can be multiple environments can be run in a single cluster by using the namespace. Right. So now here, okay, fine. I got to know like this is a namespace, so that the namespace is nothing but a private space. There I can maintain my pods. So the problem here is when I'm trying to deploy the pods into my namespace, right? So like if right now I have deployed the Nginx. Now one more pod I want to launch, like the Tomcat, some XYZ. Right. So when the moment when I want to create a pods into into the cluster, I need to provide the namespace. If you want to deploy into your own namespace, otherwise by default it will go to the default namespace. It's like some kind of irritating, because irritating means all every time providing the namespace is like it's not a good practice for me actually. So sometimes I may forget. So what will happen? It will go to the default. So now you want to make the namespace of yours as a default, not the default namespace as default. You want to make the your namespace as a default. That is also possible, right? So now converting your namespace as a default namespace, so that going forward, if you are trying to deploy anything, it will go to your namespace, not into the default namespace, right? Switching, converting means switching. So I have provided that link also here, guys. So here, so this is the command to set the namespace, so that going forward, when you are trying to deploy anything into the namespace, it will go to the particular namespace whatever you have configured. kubectl config set context current namespace equal to your namespace. So here dev env. Now here I'm going to switch the namespace from the default to my namespace called dev env. enter. So now kubectl get pods. So both are having the nginx. That is the reason we are not able to identify which namespace pod I got it. Right. So if you want to see the details, then what you can do, kubectl describe pods, then take the pod name. Now here it should show us the namespace, not the default. It should show us the dev.env namespace. Right. So likewise, you can switch the namespace from the default namespace to our own namespace by using set context, config set context, then current and the namespace name. So now going forward, whatever the pods I'm going to launch, that will be go to my namespace called dev.env. You don't require to give always -n, something like that. Right. So now here, yes. So now I got it. I got the thing like I got the things means how to deploy a pod and what are the components are going to create in the background once the pod is created, and how to see the informations, and how to create a namespace, and how to launch your pods into your own namespace. Those are we have covered so far. So now my job is done. I want to delete it. Right. So I don't want the pods. I want to delete it. Right. So now here, if you want to delete it, kubectl get pods. You can see the pods information. Now I don't require the containers because my work is done. So kubectl delete pods, then the pod name I'm going to provide here, it is deleted. Right, so it's going to delete. Now kubectl get pods, again it is going to create, right? Because the controller manager, then how I'm going to delete my pods? I don't want it now, but still it's going to create for me, right? So now here, if you want to delete the resources, nothing but the containers, you don't delete the pods. If you try to delete the pods, it will create it again because the desired state, the controller will going to create the pods for us. Now what you need to delete? We need to delete the other components called service deployments. You have to delete the other component, not the pods, so that it is going to delete all the things, all the configurations, right? So now go to the kubectl get all, right? So now the pod deletion will not be the answer for us to delete the containers, because for the replicas, it is not going to allow us to delete the pods. It is going to create it. So now you need to delete what? You need to delete the deployment. You need to delete the service. Right. So now here kubectl delete, take the name. Now nginx is deleted. Right. So now kubectl get pods. No results found. Right. So now you can observe here, right? This is the guy taking care of everything, creating the replicas, creating the pods. Will be taking care of. That is the reason. When the moment I do the deployment, automatically this is also gone, and automatically this is also gone. So means everything is going to take care by the deployment object. I will show you. I will show you how to create the deployments, how the service will see more detail. Like just trying to understand the linkings. I will try to explain the linkings, like how the linking between happening between the containers and between the parts, right? Which one has to be deleted and which one has to be managed, like that, right? So now here the deployment is the one is going to take care of everything. That is the reason when I did the deployment, automatically delete everything. That is the reason. If I ran the command get parts, I am not going to see anything. Let's see kubectl get all. That's it. Everything is gone, right? Where your namespace called dev.env, but still I can see kubectl get pods -n default, right? Because this is the pod we have deployed in our starting of the class, right? So into the default. So now here again, if you want to delete the pod into this particular namespace, kubectl delete and the component, the object name followed by the -n default. That's it. It is going to delete from the particular namespace. right? So likewise, if you want to see, right now here, I know like by seeing the get all, I know like I have the namespace called default, I have the namespace called WNV, I have the namespace called cube system, I have the namespace called cube public. So there might be other namespace you are going to create, like the other, like suppose I have created four or five namespaces as per the requirement. Now I want to see all the parts which are running in all the namespaces, not the particular namespace. I want to see the complete parts information about for the, I mean to say the complete parts information for all the namespaces. So for that, kubectl get part hyphen all hyphen namespaces. You can see default, and the default engine is running, and the rest of the parts are running on the cube system. The other namespaces are not having any part. That is the reason those are not displayed here. Right. So likewise, you can see all the namespace components information by using the hyphen all hyphen namespaces, or you can point to the particular namespace by using hyphen n followed by the namespace. Right. So now these things I want to verify from the dashboard. I want to verify from the dashboard, right? Because we have the geo option also, the components when compared to the data form. So let me go to here and go to the dashboard here. So now here you can see certain components are displaying here on the left pane: cluster, namespace, nodes, persistent volumes, rows, storage class, or something like that, blah blah blah. Right. So now here the components. That's the what are the components we have created. Sorry guys. So what are the components we have created? That will be point to the specific one namespace. Right. So now here kubectl get all. I want to see all the components of the namespace called default. I have the pod, I have the service, I have the deployment, I have the replica set. Right. So I want to see these information using the GUI. Right. If you want to see these information, you have to point to the namespace called default. That's it. Right. So now here, go to the GUI. There you can see there is an option called namespace. So which one is pointed? Default. If you select this one, you can see the other namespaces: dev, env, cube public, cube system. Right. So by default is there. Then you can find here the deployments, Nginx, Nginx, and you can see the pods, Nginx 61v9d, 61v9d. Likewise, the replica set, right? So the replicas information, replicas, and likewise the service information, right? So likewise, we can see the information here. If you want to do any updates, or you want to do any updates or deletions, you can do from here also. Right, right. The APIs can be sent by using UI or the CTL. This is the UI. Right. Suppose I want to delete the pod from the GUI, not from the CLI, not from the CLI. Right. So there, what I can do here, I will go to the pod section. Here I can observe here the actions, the three dots. Click on the actions. There you can see you can modify the pod's content or you can delete it. Let's go and delete it. Done. See here, it is deleting. Then the next one is automatically creating. So, right. So here the observation here that this is the one right now I'm trying to delete. 24 minutes ago, this one created. So in the background, is going to create one more part here because the controller, right? The replica sets. Let me refresh. That's it. A new container, a new part came into the picture 23 seconds ago. Right. So now here, if you want to see the logs information, right? The container, right? The part is nothing but a container. If you want to see the log information, simply you can go to the these three dots here, the three icons. Then this is nothing but the logs. If you click on this one, it will route to the logs. You can verify the logs, right? So likewise, you can take the actions for every service, for every component. This is the components, right? So now here Likewise, you can verify the replica sets. This is the logs. Let me go to here. Scale. We'll see. I will show you scale. What is scale here? Right. So likewise, you can take an actions. You can perform the actions from the GUI side also by go to the dashboard. So if I want to see the parts information, the components information of the cube system, right? Select the particular namespace. There you can see, right? You can see the daemons, wavenet, cube proxy, and you can see the deployments. You can see the parts, right? Whatever I have shown you, right? The replica sets, everything. You can verify from here also, right? So, but usually I'm not going to give this one to everyone because they can delete it, right? If they delete it means the cluster will be messed up. So that is the reason the GUI will not be given to the public. It is not going to expose to the public. It will be the private only, like the admins, like the DevOps force or the admins are going to have the access, not for the everyone. Okay. But yes, we have the optional GA to handle this Kubernetes stuff, like the components of the Kubernetes. Right, guys. So today I'm going to stop it here. Right. So we'll see the main core areas of the Kubernetes, nothing but the deployments. Many things are there. Still, we have many things are there. We'll discuss more in our next class. Right. So please practice it. It is very, very important for us. Right. Any questions, please let me know. Right, guys, you able to understand?
Yes, Shankar.
Thanks,
Shankar,
guys.
can we actually move the pods between different namespaces or?
Different namespaces parts we cannot move. We have to delete and we have to create into that particular namespace.
Okay.
Delete under the particular namespace, then create into the namespace like that. So that is the reason. Yeah. So that is the reason. While deploying it, we are going to mention go into the particular namespace, but a default option not there actually.
Okay. Thank you.
Yeah. Right, guys. Any other doubts? Kubernetes is somewhat easy or also somewhat complex. Like if you try to understand the easiest way, then you can fetch the other details. Like you can have the other details when you're in the project side. But anyway, I'm going to give more than 60 to 70% on the cluster side, so you don't worry about it. So then we'll see the other part like in the experience with the experience. Right, guys. So yeah. So then if you are good, let's catch up in our next weekend. Thank you.
Okay. Thank you.
Thank you.